So just to recap what we spoke about last time, even though we do supply templates with our setup, the truth of the matter is, more than likely, it's just not going to work for you. Every company has their own drawing standards, their different shop standards, different template and CAD standards, so that means customization. So the goal of the series is to give you the ability to work with the software, not against it. To do that, we need to give you a complete and accurate setup of both your software and your CAD templates that allow you to model quicker and easier and to be able to create your fabrication drawings correctly the first time. Again, we're not going to cover the installation of the software. We have a support team that does that, and we will probably not cover any generic AutoCAD template setup. What I mean by that is your dimension styles, your text styles, that sort of thing. That's information that's been well known for a long period of time, and you can discover it in the help file. What should be installed for AutoCAD MEP for this series? Well, obviously you're going to need the Fabrication for AutoCAD MEP software. That gets installed inside of AutoCAD MEP. You're going to need the parametric part wizard templates, the manufacturer-specific catalogs, and the user interface elements. And you can see from these pictures, these are different ways to tell what you have installed. You should see the Load Catalog button on the Build tab. When you go into the parametric part wizard, if you see a VAV box similar to this, then you know that you have your parametric part wizard templates installed. And if you see the EastCoast MV Parts Catalog 2014, then you know that you have our manufacturer-specific catalogs installed. And then, of course, if you go to the Support tab, you'll have our user interface elements installed, which has useful links, PDFs, user guides, that sort of thing, quick access right from the toolbar. Modeling an MEP system. I see it as a three-step process. Other people might see it differently, but the way I like to model my systems is you first add your equipment, you then create your connecting elements, and then you annotate your model. There's obviously a lot more micro steps inside of those, but if you were to break it down into a very high level, that's what you would get. We spoke about equipment. I'm not going to go too much more into that, how to get your equipment into your drawing, and some alternate choices for equipment, basically how to create your own via the content builder. This is a very advanced topic, and we're not going to cover it in this series, but I have started putting together a series in the future that would cover creating your own content, and I would add into this also using the part manager, which is the EastCoast CAD database interface. I do not lump piping accessories in with piping equipment. Your valves, your gauges, your metering devices, etc. They should be added after you've added your pipe, whereas equipment such as pumps, coils, air handling units, that sort of thing should be modeled beforehand, and you route your pipe between the pieces of equipment. And then last week I went through a demo of all the equipment, and I showed you how the different things worked. And after that, I got to thinking that I probably should have spent just a little bit of time on modeling spaces and modeling ceilings in AutoCAD MEP. I had skipped it, but after thinking about it, I went over it with the duct guys, and I thought I would touch upon it really quick for the piping guys, as it's not quite as relevant for piping as it is for duct, mainly because duct has a lot of elements that are hosted inside the ceiling, whereas piping has very few elements. Although, I mean, you can host access panels, that sort of thing inside a ceiling, but the amount of equipment that you do put on a ceiling is few and far between. So that being said, I just want to go over spaces and ceilings really quick. Spaces are a physical representation of the rooms and the areas in your building. The space is a logical element, but in AutoCAD MEP we can represent it as a physical element. It is 100% optional. You do not have to do it if you do not want to. They can be 2D or they can be 3D. It's up to you how you want to use them. They have uses for load calculations, property sets. You can assign room names for room tags. They're very useful for scheduling equipment locations. Automatic offset elevations. Currently we have a manual offset on our property sets that allow you to change the elevation of your piping inside your drawing, which is very useful for, say, if you have a server room where the elevation in that room drops down 2 feet to allow for cabling and piping. That elevation won't be reported unless you utilize the elevation offset. You could automatically report that elevation if you use spaces and you elevate your spaces correctly. Another use, since ceiling or spaces do have ceiling information in them, mainly the elevation of the ceiling, you can report whether your piping is below the ceiling or if it's above the space, or into the slab above it. All of this is done through the use of property sets. Because a pipe knows what space it's in, it can then, as it goes through a space, it can grab that ceiling elevation, it can compare it to its current elevation, and report if it's above or below the ceiling. And lastly, spaces are a container for ceiling grids. So if you're interested in showing the ceiling grid on your drawing, and you, for whatever reason, you don't want to use the architectural grids, you can certainly create a AutoCAD MEP ceiling grid, and it will follow the elevation of the space up and down. So if the architect or through coordination you need to change the elevation of your ceiling, you can change that in your space, and then it will automatically move the physical ceiling up and down according to that elevation. Spaces are great things. As I mentioned before, one of the greatest things for the piping guys is just the automatic reporting of the elevation and saying whether it's above or below the ceiling or above or below the slab. Ceiling grids, which are hosted inside of a space, are extremely useful for placing ceiling components such as duct diffusers or access space doors, because you can anchor them to the ceiling grid, and then when the ceiling grid gets adjusted, the component will move with the ceiling grid. Ceilings have the ability to have holes in them, so if you have a drop ceiling inside a gypsum board ceiling, you can model all of that. The only downside of that is the ceiling objects only have a grid look and feel. They cannot emulate gypsum board. So if you need that gypsum board look, you would have to use a hatch to get that object in there. And a little later on in the demonstration, I will go over spaces and ceilings along with some of the other things that we are going to be speaking about today. So after ceiling grids, you get those in. You sometimes need to anchor your components because they don't automatically get anchored to the ceiling grid. AutoCAD MEP offers 9 different types of anchors. The one that you will be most interested in and the one you'll probably use 99% of the time is the object anchor. It attaches one or more AEC objects to another AEC object, allowing it to move in relationship to the other. You can get to it by typing in the object anchor attach command, or you can open up the stock tool catalog in AutoCAD MEP and you can drag and drop it into your drawing, or you can drag and drop it onto a tool palette where you have access to that command anytime you want. So what are some good uses for the object anchor? Well, currently our software uses it to anchor the hanger rods to the hanger, and then the hanger itself to the pipe. So when you move the pipe, the hanger and the threaded rod move with it. You can also anchor your motor pump assembly to a concrete inertia pad, as long as that pad is an AEC object. If it's just a 3D solid or a block, then it will not work because those are not AEC objects. It would have to be a multi-view block or a AutoCAD architectural slab, or a multi-view part. It's time to start talking about actually setting up your template to where you can start routing pipe correctly. And one of the first things to do is to check your pipe layout preferences. You can get to that by going to the Manage tab, clicking on the Preferences panel, and then choosing Pipe. You can also type Pipe Preferences at the command line, and it'll bring up this pipe layout dialog. So what you do with that, your main use of that, is going to be setting your slope format. When you run slope pipe, how do you want it to look? Do you want it to be a percentage? Do you want it to be a rise run? Your choice. There's several different options there. Our default template has it set up to be a rise run with a fractional rise. So if you're sloping in 1/8 of an inch, the slope is going to be displayed as 1/8. Very intuitive to use. Has a look and feel that is normal to what you would use when you were actually sketching by hand. Elevation changes. Our template has this checked to automatically create a riser at a new elevation. What that means is as you're routing pipe, if you select the elevation option and then choose a new elevation, your pipe will automatically go to that elevation and inserting in the appropriate fitting. So if you're drawing along at an 8-foot bottom of pipe elevation and then you invoke the elevation command and then choose 20 feet, it will go ahead and put in a elbow that is pointed up and then place in a piece of pipe that goes all the way to the 20-foot elevation. It's a great option. I've seen some people that sometimes have it unchecked, and I don't understand why, because it allows you to quickly and easily get to where you need to go with your pipe. Default labels. On the sheet metal open forum, I suggested that they keep both of these to none, because they have what's called an auto tag placement that automatically places tags for them. That option is not available on the piping side. So a great alternative is the use of labels that you can set up to report different information. A great one to use is your pipe with system label. It will give you your nominal diameter of your pipe plus the system that is being used on. And currently by default the template has it set to 1 per pipe segment. So if you're routing your pipe and you're automatically breaking up the length into 10-foot sections, each pipe section will have exactly 1 label on it. There's really no difference between the label style and the flow arrow style. The drop downs for both will show the same labels. So you can place a flow arrow and a standard label, or you can place a non-flow arrow and just place a second type of label. It doesn't matter. I generally have just one being placed, and that's right inside the template. And currently our EastCoast software doesn't allow the use of routing a reducing elbow automatically, so we have this set to use the straight elbow and a reducer. If you would like to use a reducing elbow, all you need to do afterwards is just change the size of the pipe on the connector 2 of your elbow, and your elbow will update to the correct size as long as you're using an elbow that supports a reduction in size. Our standard weld bend elbow, for instance, does have a 4x3 size elbow in it. So if you change the connector 2 pipe to 3-inch, the elbow should update automatically to a 4x3 elbow. And one last thing I threw on here is with these label styles, what I like to do when drawing pipe is I like to have a couple different styles. One would be a coordination style label versus a shop drawing style label. So on the coordination label, I would have information that is only pertinent or that I need to know during coordination. The pipe size, the pipe system and the elevation. And yes, it is possible to put the elevation inside of a label. When I go to a shop drawing, I might remove the elevation from my label and put in a tag instead, because I don't need the tag. I don't need the elevation on every single segment of pipe, maybe only when I am changing sizes of pipe or changing the actual elevation. So it's possible to have two different styles of labels for two different uses, for coordination and for shop drawings. And when you're done with coordination and you're ready to move on to publish your shop drawings, all you would need to do is select one of your labels, right-click on it, select all other labels, and then just change the style right there, and it'll update your entire drawing. After the piping preferences, we move on to our routing preferences. And what our routing preferences do, and what all this text that you see here is just a straight copy out of the help file. To put it all into a quick summary, what the routing preferences do is allow you to insert your pipe fittings automatically as your routing pipe. So if you're using the EC copper press fit routing preference and you're drawing pipe, it's going to place in all of the fittings that you have defined in this dialog. So for the joints, it's going to put in a NIPCO coupling. For the elbow, now you notice that it's up here in the reducing section. There is a small bug in MEP that if you set it to the straight elbow and then you open it back up again, it's going to be in the reducing elbow section. You can disregard that because it is still just a straight elbow. But for this particular routing preference, we have our coupling, our elbow set up, we have some flex piping. Since it is a pressure pipe, we don't have a lateral or an offset defined, but we're using a Mueller pipe. And then we have a T and a concentric reducer. And this is set up for a single size range. If we move on to part 2 of this slide, there is a lot of text here. Again, to put it in a quick summary, it allows you to set up several different pipe size ranges in your routing preference. So maybe you have a routing preference where 1/2 inch through 2 inch is all copper pipe. And then when you go to 2.5 and above, you change the material of your pipe to all your welded fittings. And so that allows you to use one routing preference. 2 inches and below will be copper, and 2.5 and above will be welded. And we'll get into that a lot more when we're actually physically routing pipe. Our system definitions. I like to explain the system definitions and the routing preferences as the routing preference tells the program what part to put in your drawing, and the system definition tells the program how to display that part. They're typically named, and this is incorrect. They're not. The routing preference is typically named for the type of material. The system definition is typically named for the type of system. So system definitions work in conjunction with your routing preferences. You can have a single system called chilled water that might have 3 or 4 different routing preferences in it. It might have a routing preference of just copper pipe. It might have a secondary routing preference of welded pipe. And then in the mechanical room, it might have grooved fittings along with grooved copper fittings. So you can have many different routing preferences with a single system. When you select a pipe segment system, you can change the system on all of the connected components at once. Same with your routing preference. You don't need to individually select the items. You can select one item in the system and then tell the software to choose that entire system, and you can update everything at once. To access the display manager, it's similar to how you would access the routing preferences, and everything is done inside the style manager. To get there, you can go to the Manage tab, click on the Style and Display panel, select the Style Manager drop-down, and then select your piping system definitions. This will bring up the Style Manager filtered to where you only see your piping system definitions. So what do you set inside your system definitions? Well, as I said before, it basically determines how the pipe will look on paper. You control your layers through your layer key styles, and we've spoken about layer key styles in the past. We have a whole open forum on that. To summarize it, what a layer key style does is when you tell the software you want to start routing a specific pipe system, it checks to see what layer key style is assigned to that pipe system, and then it looks at the layers in your drawing. If the layer assigned to that layer key style has not been created, then it will go ahead and create it with all of the specific portions of the layer assigned the way it is defined inside the layer key style. So the color, the line type style, the description, the transparency, all of that is defined in your layer key style. And if it doesn't find the layer in your drawing, it'll go ahead and create it using those settings. If you start your pipe add command and choose your system, and it looks to see if that layer is already defined in your drawing, then it will, and it is defined, then it will do nothing else. So even if the layer in your drawing has settings different than what's in the layer key style, it doesn't care. All it looks to do is see if that layer exists. Subtle difference there, but it does play a part. If you change your layer key style settings, it will not update any existing layers. The system definition also allows you to control your rise drop style. So how does your pipe look when it rises up? How does it look when it drops down? It also gives you control over your single line graphics. So if you have a 4-inch pipe, you can tell it to display as a single line for a single system. Maybe another system it changes to a single line at 6 inches. And another system it changes at 8 inches. There's a whole lot of control you can get over that, and we went over it in one full session back in the September 23rd Open Pipe Forum. So if you go to our website and go into the open forums and scroll down to September 23rd, you'll see a whole session on the single line graphics. Same thing with the system style display override. On February 3rd, we spent a whole hour on those. And basically what the system style display override allows you to do is to display that system differently than other systems. The out-of-the-box templates make use of that for your cold water and your hot water return. So pipe is displayed a certain way in your entire drawing, but those 3 particular systems are displayed differently. And it's mostly prevalent in the single line display. So the 3 different systems have a single dash, a double dash, or a triple dash in single line display, depending on the system. So going back to spaces, when you add a space, you can use the space add command like anything else you do in AutoCAD MEP, and then go ahead and just add the space. Once it's added, you have grips to move it to any size that you want. If we look at it in a 3D view, you can see that it certainly is 3D, and that's because I have the geometry type on the property palette set to extrusion. If I was to change that to 2D, you can see that my space immediately goes to 2D. I change that for all of them. If we go back to extrusion in 3D, when I select a space, it gives you a lot of different geometry you can control. So I can control the height of that space, take it up to my under slab elevation, and then I can control the ceiling of that space, 9 feet. Like every other object in AutoCAD MEP, the plan view can have the ability to look different than the isometric view. If you want to modify that, the quickest way to do it is to right-click on the object, go to Edit Object Display, and I am going to click over here on Plan Screened versus checking on the Object Override, because I want to modify all objects in my drawing. So if I come over here, and then just select my base hatch and turn it off. Then hit OK, OK. You can see that that hatch goes away. And the reason why we probably want the hatch to go away is if we add a ceiling. And like anything else, if you use the ceiling grid add command, it will allow you to add a ceiling. Now before I add this, one thing that I want to do is I want to change my boundary to select object. So then when I go and start the ceiling grid add command, it's going to ask me to select a space or a closed polyline for a boundary. I'm just going to choose this space here. Then I'm going to come and I'm going to change my snap to center so it snaps to the center of that space, and then I'm just going to change my rotation. And you can see that that ceiling grid is indeed snapped to the center of the space. If I select it, you can see that it actually overruns the space, but it's being hatched to be turned off outside the space. So if I just come up here, place it there, and place this over here. And you generally don't want to go too far outside the space. That just takes up extra memory in your drawing. So if we go back to 3D, we can see that that ceiling was placed down below, and that is because our elevation, we had gone back and forth between 2D and 3D, but if we modify our elevation really quick, we can see that it will snap up to where it needs to be, and then as we change our elevation, the elevation of our ceiling will move with it. So that was spaces and ceiling grids in a nutshell. If we look at our piping preferences, you can see with the drop-down, several different ways to display your pipe. Just choose the one that's most prevalent in your organization. We didn't talk about connection assignments. It's best to just leave this alone and let the software handle that. This is a basic webinar, and modifying these is a very, very advanced topic. And then you can, as I said before, you can change your labels. If you notice, the flow arrow labels show up no matter whether you're on the flow arrow style or the label style. So you can choose whichever one you want. Routing preferences, which are found if you open up just the style manager, you can come down to piping objects and then select your pipe routing preferences. Or if you want to, choose the drop down here and then choose your pipe routing preferences. It'll open up the style manager filtered to just the routing preferences, so you cannot select anything else. If we choose one of those styles, here we have the ability to change the name, add a description, and then even add some notes to that if we want, and select some Word documents, PDFs, whatever to add to that routing preference. So in the routing preference itself, as we spoke about, there is a size range. This particular routing preference has a single size range from 1/2 to 4 inch. If I choose a thread by weld routing preference, you can see that this one has 2 size ranges, and it changes size at 2.5 inches. So at 2.5 inches, it will start drawing weld bin fittings, whereas anything 2 inches and below, it was drawing your threaded fittings. And there are a couple different preset East Coast routing preferences. We don't supply a great amount of them because most companies modify and create their own right away. There are also some out-of-the-box routing preferences in here that use the out-of-the-box standard AutoCAD MEP parts. Real quick, our system definitions. There are several different system definitions defined in the Style Manager already. If you need more, you can open up a style drawing that is found in your, let's see if I can find it here. It is found in your C drive, your program data, Autodesk, MEP 2014 in English. Then under your styles directory, Imperial, and let's change this to DWG, and you'll see a lot of style-based drawings here. If you open up your system definitions and hit open, and come over here on the right and look at all of these, you're going to see what's probably a couple hundred different system definitions in here that you can use for your own drawings. So what's there in the standard template is not what's just available. There's more to be had if you want. And if we look at those really quick, there is the Design Rule tab where you can set the abbreviation of that system. You can change what system group it belongs to. Groups of different systems cannot connect to each other. A good use of that is if you're running a plumbing system and you have non-potable water as one system group, and maybe you have potable water as another. It will not allow you to connect those system groups together, so you cannot contaminate your drinking water as long as you pay attention to systems that are connected and not connected. You set your layer key here. I'm not going to go into how to do your overrides and things like that. As I said before, we touched upon that in a previous webinar, so we can go back and look at those to actually see how to do it. But just be aware that this is what tells the system what layer to put your pipe on. Your rise and drop styles we spoke about. There's two that shipped with the software. You can have one with a pattern and one without a pattern. Our single line graphics. The chilled water is set up to not display in single line at all, which is how most of the hydronic systems are set up. If you choose even the domestic cold water and heating hot water are, but you could certainly come in here and say for any size less than 4 inches, I want to display it as single line. And again, there's an entire 1 hour open forum that goes over just this. And the same thing with the display properties. Coming in here, you can see that we're currently in a model isometric, so this is bolted up. If I came over here and selected this, you can see that I'm going to open up the drawing default. That means any changes I make on this side is going to change piping in the entire drawing. If in contrast I come over here and select the style override, then you can see up here it says pipe system definition override for this system. Any changes I make here will only show up for this heating hot water supply system. Thank you, everyone. We'll talk to you later.